The evening of July 13th, 1944. A Sherman tank sits motionless in a maintenance yard 3 miles behind American lines near Colombières, Normandy. Sergeant Curtis Culin crouches beneath it, welding torch in hand, molten steel dripping onto dirt already scorched from 6 weeks of improvised repairs. The modification he's creating violates at least 4 Army regulations. If it fails during tomorrow's demonstration, his career is finished. If it succeeds, it might save thousands of lives. But success isn't guaranteed, and tomorrow morning, General Omar Bradley himself will watch this unauthorized experiment either work or explode spectacularly. Culin is 29 years old. He's been in France for 38 days. In that time, he's watched the Normandy bocage devour American armor at a rate that makes the training manuals look like fantasy novels. The problem isn't German firepower, though that's lethal enough. The problem is physics, geometry, and 600 years of French agricultural history compressed into earthen walls that turn every field into a fortress and every Sherman tank into a target. The bocage wasn't supposed to be this bad. Intelligence reports mentioned hedgerows. Training exercises in England included hedgerows. But Norman hedgerows aren't the manicured English boundaries that officers studied during preparation. They're ancient fortifications disguised as farmland. 4 feet of compacted earth and stone topped with 15 feet of interlocking roots, dense brush and mature trees. Some of these barriers have been accumulating mass since medieval farmers first cleared these fields. Centuries of stones piled on stones, vegetation growing and dying and regrowing, root systems intertwining until the entire structure becomes nearly as solid as concrete. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The German defenders understood what they had. Every hedgerow became a prepared fighting position, machine gun nests carved directly into the earthen banks, protected from overhead artillery. Anti-tank guns positioned to cover the narrow gaps between fields, sniper positions elevated in the trees with perfect sight lines down the sunken lanes. The Americans called it the Green Hell. The Germans called it perfect defensive terrain. American doctrine said tanks should climb over hedgerows. That was the training. That was what worked during exercises back in England. Drive at the hedgerow at speed, let the tank's momentum carry you up and over, break through to the other side. Simple. Effective, except it wasn't. When a 30-ton Sherman climbed a Norman hedgerow, the tank tilted upward at a 45-degree angle. The thick frontal armor, designed to stop German 88mm rounds, pointed uselessly at the sky. The belly armor, a third as thick, pointed directly at German anti-tank positions hidden in the next hedgerow. For 5, maybe 6 seconds, the Sherman couldn't fire its main gun, couldn't see forward, couldn't defend itself. The tank crew knew exactly what was coming. The German gunners in the next field knew exactly where to aim. The statistics told the story. First Army lost 231 tanks in June alone, most destroyed in the bocage, most killed during hedgerow crossings. The casualty rate among infantry was worse. Between June 6th and July 31st, rifle companies lost nearly 60% of enlisted men and over 68% of officers. Companies that landed on Omaha Beach with full strength were operating at 40% by mid-July, not because of one big battle, but because of hundreds of small ones, field by field, hedgerow by hedgerow, grinding attrition that consumed units faster than replacements could arrive. The official solution involved combat engineers with explosives. Approach a hedgerow, place charges, blow a gap, push tanks through, before German artillery zeroed in on the obvious breach point. This method killed engineers even faster than it killed tankers. The explosions announced American intentions to every German position within 1,000 yards. Artillery started falling before the first tank could move forward. Machine gun fire swept the gap. Engineers trying to place the next set of charges were cut down. The tanks that made it through were immediately engaged by pre-sighted anti-tank guns. Several units tried developing their own solutions throughout late June and early July. The 79th Infantry Division demonstrated a hedgerow cutter by July 5th. The 19th Corps tested prongs initially designed for placing explosives. The 5th Corps created devices called brush cutters and green dozers. But none of these modifications spread widely. Most required specialized equipment or extensive modifications that field units couldn't replicate quickly enough. Curtis Culin's unit, the 102nd Cavalry Reconnaissance Squadron, had been discussing the Hedgerow problem since their first week inland. They were New Jersey National Guard, the Essex Troop, with lineage dating back to the Revolutionary War. The squadron landed on Omaha Beach on D-Day +1 and had been in continuous combat since June 7th. Unlike infantry divisions that rotated for rest, cavalry reconnaissance operated continuously. They screened advances, conducted patrols, gathered intelligence, fought wherever needed. The men came from industrial backgrounds around Newark and surrounding areas. Factory workers, machinists, welders, men who understood mechanical problems and knew how to improvise with limited resources. The Depression had taught them to make do with what they had. These weren't West Point engineers with advanced degrees. These were working-class soldiers who fixed cars in civilian life and now fixed tanks under artillery fire. The breakthrough concept emerged during a maintenance yard conversation in early July. Private Roberts from Tennessee, a hillbilly as the other men called him, made an offhand remark during a discussion about hedgerow tactics. "Why don't we just put some saw teeth on the front and cut through these damn things?" Most of the mechanics laughed. Cut through a hedgerow? These weren't wooden fences. These were earthen fortifications that had resisted centuries of weathering. But Curtis Culin didn't laugh. He understood what Roberts was suggesting. Not cutting through vegetation, but concentrating force at the base of the hedgerow where the structure was weakest. Let the tank's 30-ton weight drive steel prongs through the compacted earth. The hedgerow would split from the bottom up. The raw material was everywhere. The invasion beaches were still covered with German obstacles, Czech hedgehogs, steel beam barriers designed to rip bottoms out of landing craft. Each hedgehog consisted of 3 steel I-beams welded together in an X shape. The beams were high-grade steel, approximately 5 feet long, already cut and angled. There were thousands of them scattered across the beaches, casualties of the invasion now just sitting in salvage piles. Culin drove to the beach near Vierville-sur-Mer the next morning. He found a salvage pile 20 feet high with Czech hedgehogs stacked like cordwood. Nobody questioned what he was doing. Salvage operations happened constantly. He selected an intact hedgehog, borrowed a cutting torch, separated the beams, and loaded 4 sections onto a truck. Total time, 45 minutes. Back at the maintenance yard, he spent the rest of the day measuring and planning. Each beam needed to be approximately 4 feet long for sufficient penetration depth. The ends needed cutting at angles and sharpening to concentrate force. The prongs needed spacing, wide enough to divide the hedgerow mass, but close enough to prevent the tank from belly up between them. The welding work started after midnight on July 9th. Most of the unit slept. The only sounds were generators running and occasional artillery rumbling in the distance. Culin worked alone, under a tarpaulin, to hide his welding torchlight. He positioned the first beam against the Sherman's front hull, low, angled slightly downward. The beam had to weld directly to the transmission housing for maximum strength. He tacked it in place, checked the angle, then laid a full weld bead. The steel was thick. The weld had to be solid. He worked slowly, methodically, making sure every joint was complete. The second beam went on the opposite side. Symmetry was critical. If the prongs were uneven, the tank would pull to one side during breach. He measured twice, welded once. The third and fourth beams went in the center, spaced 18 inches apart. By 3 in the morning, all 4 prongs were welded in place. The modification added approximately 300 pounds to the front of the tank. The steel prongs stuck out 42 inches from the hull, angled downward at 20 degrees. Culin stepped back and examined his work. The Sherman looked aggressive, predatory. The 4 steel prongs gave it the appearance of some mechanical beast. The other tankers would probably laugh. The officers would definitely have questions. But if it worked, if it let the Sherman cut through hedgerows without exposing belly armor, then regulations could wait. He cleaned up the work area, hid the welding equipment, walked back to his tent at 4 in the morning. He didn't sleep. He lay on his bunk staring at canvas and thinking about what would happen if the modification failed, if the welds broke during impact, if the prongs bent, if the tank flipped over, if soldiers died because of something he built without authorization. But doing nothing meant soldiers would definitely die. That wasn't a possibility. That was certainty. The Hedgerows were killing Americans every single day. At 6:30, Culin found Captain James Dupuy, one of the squadron officers. He showed Dupuy the welded prongs and explained the concept. Dupuy listened without interrupting. When Culin finished, Dupuy said they needed to test it before anyone from battalion saw it. If it worked, they could show senior command. If it failed, they'd remove the prongs and reconsider the approach. They drove the modified Sherman to an abandoned field behind American lines at 9 in the morning. There was a hedgerow there, typical Norman construction. Approximately 4 feet of earthen berm topped with 10 feet of dense brush and small trees. No Germans, no observers, just Culin, Dupuy, and the tank crew. Culin climbed into the driver's position. Dupuy stood outside to observe. Culin started the engine, engaged the transmission, drove toward the hedgerow at 10 miles per hour. The steel prongs hit the base. There was tremendous impact. The tank shuddered. For a moment, Culin thought the welds had failed, but the Sherman kept moving forward. The prongs bit into packed earth. The tank's 30 tons of weight drove them deeper. The hedgerow split apart. Dirt exploded outward. Vegetation collapsed across the tank's hull. The Sherman burst through to the other side in 4 seconds. All 4 tracks stayed level. The belly armor never exposed. The main gun stayed on target. Dupuy was calling out observations. Culin could barely hear him over engine noise. He reversed, back through the gap, shut down the engine, climbed out. Dupuy was examining the breach. The hedgerow had a ragged hole torn through it at ground level, approximately 8 feet wide. Clean breach, no explosives, no exposed belly, no vulnerable moment. Dupuy said they needed to show this to senior officers who could authorize wider adoption. What neither Culin nor his fellow squadron members realized was that word was already spreading. Other tank crews had watched the test. They saw tanks breaching at ground level without exposing belly armor. They saw a solution to the problem that had been killing them for 6 weeks. Tankers from other units started asking about the modifications. Some battalion commanders refused. The modifications were unauthorized. They violated Army regulations regarding vehicle alterations. Installing them could void warranties and create liability issues. Other commanders looked at their casualty reports and decided regulations could wait. Mechanics from other units learned the technique. They found check hedgehogs on beaches, cut the I-beams to 4-foot lengths, sharpened the ends at angles, positioned them on front hulls low enough to strike hedgerow bases, spaced them to divide mass evenly, welded them solid with full penetration welds. The modifications spread through informal networks. A tank commander would see a modified Sherman and ask where it got the attachment. The crew would point to their motor pool. The tank commander would talk to his mechanics. The mechanics would find someone who knew the technique. By mid-July, mechanics in multiple battalions were installing hedgerow cutters. By July 13th, Culin had modified 9 tanks. Tank commanders who had lost crews in hedgerows heard about the modifications from motor pool mechanics. Platoon leaders who watched their Shermans burn after exposing belly armor started asking questions. Where could they get the steel prongs? Who knew how to install them? How long did it take? Some battalion commanders refused outright. They had not been tested by ordnance. They had not been approved by Tank Destroyer Command. Installing them could void the Sherman's warranty, create liability issues, result in disciplinary action if something went wrong. Other commanders looked at their casualty reports and decided regulations could wait. They had lost 30% of their armor strength in 3 weeks. Crews were refusing to cross hedgerows without engineer support. Engineer casualties were approaching 50% because German artillery targeted every demolition team. Something had to change. Culin showed mechanics from other units how to do the work. He walked them through the entire process. Find, salvage, check hedgehogs on the beaches. Cut the I-beams to approximately 4-foot length, sharpen the ends at a 30-degree angle, position them on the front hull low enough to strike the hedgerow base, Space them to divide the mass evenly. Weld them solid, not just tack welds, full penetration welds that would hold under impact. Test the welds before declaring the job complete. The mechanics learned quickly. Most were experienced welders who had worked in factories or repair shops before the war. They understood structural loads and stress points. They knew how to make field repairs that would hold under combat conditions. Within 2 days, mechanics in 3 different battalions were installing Hedgerow cutters on their units' tanks. The modifications spread crew to crew, unit to unit through informal networks. A tank commander would see a modified Sherman cut through a hedgerow and ask where it got the attachment. The crew would point to their unit's motor pool. The tank commander would talk to his mechanics. The mechanics would talk to Culin or one of the other soldiers who had learned the technique. By mid-July, the knowledge was spreading faster than official communications could track. No official documentation existed, no engineering drawings, no approved specifications, no installation procedures, just soldiers teaching other soldiers how to weld German scrap metal to American tanks because it worked, and the official solutions were getting people killed. Some mechanics made subtle variations, 5 prongs instead of 4, different angles, longer or shorter lengths. Each crew tested their own modifications and adjusted based on results. On July 14th, word reached division headquarters. An inspection officer noticed several tanks in 2nd Armored Division had unauthorized modifications on their front hulls. He reported it up the chain. Instead of ordering the modifications removed, Division Commander Major General Edward Brooks requested a demonstration. General Omar Bradley was visiting 2nd Armored Division that day as part of pre-mission planning for Operation Cobra, the planned breakout offensive scheduled for late July. Brooks asked Bradley if he had time to see something interesting. Bradley agreed. They drove to a training area near Colombières where Culin's Sherman was waiting. Bradley arrived at 0730 hours. He saw the modified tank with its 4 steel prongs and asked what he was looking at. Culin explained the modification. Bradley listened, then asked for a demonstration. Culin climbed into the driver's seat. His crew mounted up. The tank backed away from a hedgerow approximately 50 yards. Bradley stood with Brooks and several staff officers. Culin engaged the transmission and accelerated toward the hedgerow. The Sherman reached 10 miles per hour. The steel prongs hit the earth and berm. The hedgerow exploded. Dirt and vegetation erupted outwards. The tank burst through under a canopy of falling debris. 4 seconds. Clean breach. The Sherman emerged on the other side with all systems operational. Bradley stood there for a moment, not saying anything. Then he walked to the gap and looked at the torn hedgerow. The breach was approximately 8 feet wide, ragged edges, base torn out at ground level. He asked Culin how long it took to install the modification. Culin said approximately 6 hours per tank if the welder knew what they were doing. Bradley asked if the materials were available. Culin said the beaches were covered with German obstacles, enough steel to modify hundreds of tanks. Bradley turned to his staff and said to get every ordnance unit in 1st Army working on this immediately. He wanted as many tanks as possible modified before Operation Cobra. The attack was scheduled for July 25th. That gave them 11 days. Bradley ordered Lieutenant Colonel John Medaris from Ordnance to coordinate production. Medaris was told to use every welder, every maintenance unit, every salvage team available. 3 out of every 5 tanks in 1st Army needed these modifications before the offensive started. Culin stood there, watching generals and colonels discuss his unauthorized modification like it was official policy. Nobody mentioned court-martial. Nobody talked about regulations. They were talking about production schedules and welding crew assignments. For his work, Culin was recommended for the Legion of Merit. 3 other men from the 102nd Cavalry also received the Legion of Merit for their roles in developing and manufacturing the Hedgerow cutter. Major Arthur Pinson and Captain James Dupuy, the squadron's senior officers who supported the unauthorized project. Captain Stephen Linton, who helped refine the design. Culin was the sergeant who built the prototype. But the final device was a collaborative effort. The official recognition understated the grassroots nature of the invention. Bronze Stars went to the tank drivers who tested the early prototypes under fire. Technical Sergeant Harmon McNaughton, Private John Huey. Bronze Stars also went to the welders who manufactured hundreds of devices in field workshops. Technical Sergeant Wesley Hewitt, Technical Sergeant John Jesson, Technical Sergeant Ernest Hardcastle, These were the men who turned one experimental attachment into an army-wide modification in less than 2 weeks. Over the next 11 days, American ordnance units worked around the clock manufacturing hedgerow cutting devices. Bradley had ordered Medaris to coordinate production. Medaris established manufacturing priorities immediately. Every ordnance unit in First Army was assigned quotas. Welding crews worked in shifts. Salvage teams stripped Czech hedgehogs from the beaches faster than they had been removing them. The devices were called rhino attachments. Some called them Culin cutters. Each device was slightly different because they were handmade in field workshops, but the basic design remained consistent. 4 steel prongs welded to the front hull, cut from German beach obstacles, angled downward 20 to 30 degrees, strong enough to split a hedgerow, spaced to divide the mass evenly. The work required skilled welders. These were not simple tack welds. The prongs had to withstand tremendous impact forces. Full penetration welds were essential. The steel had to be fused to the hull structure so it wouldn't tear away on first contact. The men who did this work were experienced craftsmen. Technical Sergeant Wesley Hewitt had been a welder in civilian life. Technical Sergeant John Jesson had worked in a shipyard. Technical Sergeant Ernest Hardcastle had maintained industrial equipment. These were the men who turned one experimental prototype into hundreds of combat-ready modifications. The tank drivers who tested the first devices also received recognition. Technical Sergeant Harmon McNaughton drove one of the first modified Shermans through a hedgerow under fire. Private John Huey tested another early model during combat operations near St. Lo. Both men received Bronze Stars for their role in proving the concept worked under actual combat conditions. By July 24th, approximately 500 tanks in First Army had been modified. Shermans, Stuarts, even some M10 tank destroyers. The modifications covered approximately 60% of the armor going into Operation Cobra. Some units had modified nearly all their tanks. Other units had only a handful. The capability was spreading faster than official channels could have approved it. Then the Germans noticed something had changed. German infantry first reported unusual American tank activity in late July. Forward observers noted that American tanks in some sectors were no longer always climbing over hedgerows. In certain engagements, tanks were cutting through at ground level. The reports were filed but initially received limited attention. American tactics changed frequently as units learned and adapted. By late July, patterns emerged. German anti-tank crews reported that tactics which had worked reliably were failing more often. They would position guns to cover hedgerow crossing points where American tanks typically exposed their belly armor during climbs. But increasing numbers of American tanks were breaching at ground level with frontal armor protected. Guns positioned for high-angle belly shots found themselves engaging frontal armor instead. Similar reports came from German positions across the front. American tanks were breaching hedgerows in seconds without exposing vulnerable points in ways that had not been common earlier in the campaign. Tactics that had worked for 6 weeks were succeeding less consistently. German anti-tank crews were losing their predictable advantage. Senior German officers tried to understand what had changed. They examined wrecked American tanks, looking for modifications. What they found were crude steel prongs welded to the front hulls. The purpose wasn't immediately obvious. The steel looked like salvaged beach obstacles. Some officers thought it was improvised armor. Others thought it was designed to trigger mines before the tank's main hull reached them. Few understood it was specifically designed to exploit the hedgerow's construction. By late July, German defensive plans started adjusting. Anti-tank guns that had been positioned to fire at hedgerow crossing points were being moved. Units that had relied on the bocage to channel American tanks into kill zones were being repositioned. The hedgerows were no longer reliable obstacles. The psychological impact on German defenders was significant. For 6 weeks, the bocage had been their greatest asset. Every hedgerow was a defensive position. Every field was a strong point. The terrain did most of the work of stopping American armor. German infantry could fight from prepared positions and let the hedgerows do the killing. That advantage was gone. American tanks were cutting through hedgerows faster than German infantry could reposition. Defensive plans that depended on controlling specific gaps were useless when the Americans could make their own gaps anywhere they wanted. Units that tried to use old tactics found themselves being outflanked by Shermans that appeared from unexpected directions. Some German commanders tried to adapt by thickening their hedgerow defenses, additional obstacles, more mines, deeper fighting positions. But obstacles that stopped a climbing tank didn't stop a tank cutting through at ground level. The modifications didn't care about additional barriers. They cut through everything. Operation Cobra launched on July 25, 1944. The offensive began with a massive aerial bombardment. Over 1,500 heavy bombers and 350 medium bombers dropped more than 4,000 tons of bombs on German positions south of Saint-Lô. The bombardment was meant to shatter German defenses and open a corridor for American armor to exploit. The first day, results were mixed. The bombing had been partially effective, but also caused significant American casualties from short drops. Ground forces advanced, but encountered stiff German resistance in many sectors. The hedgerows still channeled movement. German defensive positions still took advantage of every piece of terrain, but tanks equipped with hedgerow cutters made a difference. They could breach at unexpected points. They could create their own gaps instead of using predictable crossing points. They could support infantry advances without waiting for engineers to blow paths through every hedgerow. The tactical flexibility was significant, even if the devices didn't revolutionize the battle overnight. First Army advanced 7 miles on the first day, 12 miles by the second day. German defensive lines that should have held for days were overrun in hours. By July 28th, American forces had achieved a breakthrough. German units were withdrawing. The bocage stalemate was over. By July 31st, the breakout was complete. American armor was in open country beyond the bocage. Third Army under General Patton passed through this gap and began its rapid advance across France. The hedgerows that had protected German defenders for 6 weeks were behind the advancing American forces. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The hedgerow cutters played a supporting role in this success. Historians debate their tactical importance. Some argue they were psychologically significant, boosting morale and giving tankers confidence. Others argue the devices had limited practical effect, since armor primarily advanced on roads during the breakout rather than cross-country. The truth likely falls somewhere between. The modifications helped in specific tactical situations and contributed to overall combat effectiveness without being the single decisive factor. German commanders filed reports trying to explain how American forces had achieved such rapid breakthrough. Most cited overwhelming firepower and air superiority. Some mentioned new tank tactics. Few understood that the breakthrough started with scrap steel welded to tank hulls by soldiers who didn't wait for permission. The modification was never officially credited to any engineering department or design bureau. After the war, American armor development reports mentioned hedgerow cutting attachments as field-expedient modifications developed in theater. Curtis Culin's name appeared in some unit histories, but not in official army documentation. Culin didn't receive public recognition during the war. He was awarded the Legion of Merit in September 1944 for exceptional service. The citation mentioned his contribution to armored operations in Normandy, but didn't specify the hedgerow cutter invention. 4 months after the demonstration for General Bradley, Culin was wounded by a German landmine in the Earthen forest. The explosion severed his left leg below the knee. He was evacuated to a field hospital, then to England, then back to the United States. His war was over. He spent 6 months recovering at an army hospital in New Jersey. Physical therapy, learning to walk with a prosthetic leg, adjusting to the reality that his tanker days were finished. He was discharged from the army in March 1945 with a Purple Heart and a medical retirement. Culin married Bernice Enright in June 1945. They settled in New York City. He took a job as a salesman for Schenley Industries, a liquor distributor. The work was different from anything he'd done before. No more tanks, no more maintenance, no more welding German scrap metal in the dark, just sales calls and client meetings and trying to build a normal life. He didn't talk much about the war. When people asked, he would say he worked on tanks in Normandy, fixed engines, maintained equipment, that was all. He never mentioned the hedgerow cutters unless someone specifically asked. Even then, he kept it brief. It was just something that needed doing. He emphasized the collaborative work, the other men from the squadron who built and tested the devices. Veterans of the 102nd Cavalry kept in touch after the war. They formed an association, held reunions, maintained the history of their unit. The hedgerow cutter remained a source of pride. The squadron's official history documented how enlisted mechanics and officers worked together to develop a battlefield innovation that senior command quickly adopted. General Bradley mentioned the hedgerow cutter in his memoir, A Soldier's Story, published in 1951. He described watching the demonstration and realizing that sergeants and mechanics had solved a problem that had stalled First Army for weeks. Bradley wrote that the device was so absurdly simple it had baffled an army for more than 5 weeks. He credited Curtis Culin by name, though he incorrectly listed him as Curtis G. Culin Jr. rather than the third. President Dwight Eisenhower mentioned Culin in one of his last speeches as president in January 1961. Speaking to the American Society of Mechanical Engineers, Eisenhower told the story of a sergeant who had an idea about putting knives on tanks to cut through hedgerows. Eisenhower said, "The idea went from captain to major to colonel until it reached General Bradley, and Bradley acted on it immediately." Eisenhower used the story to illustrate that innovation in wartime comes from soldiers in the field, not from headquarters. Eisenhower repeated the story in 1964 during a CBS interview with Walter Cronkite. The interview was filmed in Normandy on the 20th anniversary of D-Day. They stood near a hedgerow. Eisenhower described how the bocage had nearly stopped the American advance and how one sergeant's improvised solution changed everything. He said the invention gave the Army back its mobility and made Operation Cobra possible. Curtis Culin never saw most of this recognition. He lived quietly in New York City, working as a salesman. He and Bernice divorced in the early 1950s. He continued working for Shenley Industries. He walked with a prosthetic leg and rarely mentioned his military service. In 1963, Curtis Culin died of a heart attack in Greenwich Village. He was 48 years old. His obituary in the New York Times mentioned his service in World War II as a tank sergeant. It mentioned the Legion of Merit. It didn't mention the hedgerow cutter. It didn't mention that his modification helped break the stalemate in Normandy. It didn't mention that he violated regulations to save lives. There is a memorial to Curtis Culin in his hometown of Cranford, New Jersey. A bronze plaque mounted on a boulder outside the municipal building on North Union Avenue. The plaque includes Eisenhower's quote about the sergeant who had an idea. A street in Cranford was also named Culin Drive in his honor. Residents walk past the memorial daily. Most don't know the full story. Most don't know that the modification was initially unauthorized. Most don't know about the other men from the 102nd Cavalry who contributed to the invention. In 1998, a military historian researching Operation Cobra found references to hedgerow cutting modifications in 2nd Armored Division maintenance logs and 102nd Cavalry Squadron records. The historian tracked down surviving members of Cullin's unit through veteran registries. Several remembered Culin. They remembered the modified tanks. They remembered the demonstration for General Bradley. They remembered that the modifications spread through multiple units in less than 2 weeks through informal soldier networks. The historian estimated that the hedgerow cutters contributed to reducing American tank casualties in the bocage. Though precisely quantifying the impact remained difficult, the devices changed tactical options available to tank commanders. Instead of exposing belly armor during every hedgerow crossing, tanks could breach at ground level with frontal armor protected. Instead of waiting for engineers to blow gaps, armor could create breaches on demand. Instead of predictable crossing points that German gunners could cover, American forces could attack from varied directions. Post-war analysis by the United States Army Center of Military History examined the Normandy campaign in detail. The studies concluded that multiple factors contributed to the eventual breakout from the bocage. Overwhelming Allied air superiority, superior numbers of tanks and artillery, better logistics, improved combined arms coordination between infantry, armor, and engineers. The hedgerow cutters were one tactical innovation among many that collectively enabled Operation Cobra's success. Military historians continue to debate the hedgerow cutter's significance. Some emphasize its psychological importance. The modifications boosted morale among tankers who felt they finally had a tool to deal with the bocage. Knowing they could cut through hedgerows without exposing vulnerable bellies gave crews confidence to push forward more aggressively. Other historians emphasized tactical flexibility. Even if tanks often advanced on roads during the breakout rather than cross-country, the option to breach hedgerows at unexpected points forced German defenders to spread their limited anti-tank assets more thinly. German units could no longer concentrate defenses at a few predictable crossing points. Still, other analysts argue the devices had limited practical effect. Most armored advances during Operation Cobra followed roads and existing gaps rather than cutting through hedgerows systematically. The massive aerial bombardment and overwhelming force concentration mattered more than any single tactical modification. The hedgerow cutters helped at the margins, but didn't fundamentally change the battle's outcome. The truth likely encompasses all these perspectives. The hedgerow cutters were neither the decisive, war-winning innovation that some popular accounts suggest, nor were they militarily insignificant. They represented an important example of how frontline soldiers identify problems and develop practical solutions faster than official channels. They demonstrated that tactical innovation often emerges from the bottom up rather than top down. The story also illustrates organizational dynamics in military forces. The 102nd Cavalry developed the modification outside official channels because official channels moved too slowly. Ordnance was studying the hedgerow problem. Engineers were testing demolition techniques. But none of these official efforts produced a solution that spread widely enough, fast enough to help the units fighting in early July. The soldier built what they needed with materials at hand. General Bradley's decision to embrace and rapidly scale an unauthorized modification showed leadership flexibility. He could have ordered the devices removed for violating regulations. He could have insisted on formal testing and engineering approval. Instead, he recognized a practical solution and mobilized army resources to manufacture hundreds of devices in less than 2 weeks. That kind of rapid decision-making, bypassing normal bureaucratic processes when circumstances demanded speed, contributed significantly to American success in Normandy. That's how innovation actually happens in war, not through official channels or engineering committees, but through mechanics and tankers working together to solve problems, through soldiers welding scrap metal to tanks because it worked, through crews testing modifications under fire, through junior officers and senior enlisted men willing to break regulations when lives were at stake. Curtis Culin received the most public recognition. But the hedgerow cutter was the work of many hands. The welders who built hundreds of devices in field workshops, the tank drivers who tested early prototypes, the officers who supported the unauthorized project, the mechanics who spread the technique across multiple units. All of them contributed to a battlefield innovation that changed the course of the Normandy campaign. Curtis Culin was not supposed to modify his tank. He was not authorized to weld German steel to army equipment. He was not cleared to change his vehicle's performance characteristics. The regulations existed for good reasons. Unauthorized modifications could compromise safety. Untested changes could cause equipment failures. Field mechanics lacked the engineering expertise to evaluate structural loads and stress factors that professional designers considered, but Culin did it anyway because the official solutions weren't working fast enough and soldiers were dying. That tension between following proper procedures and taking action to save lives defines many military innovations. Sometimes the rule book provides the answer. Sometimes survival requires writing a new page. The hedgerow cutter story became part of American military culture. Officers studying at the command and staff colleges learn about it as an example of tactical innovation under pressure. The case study illustrates how frontline units adapt to unexpected battlefield conditions. It demonstrates the value of decentralized initiative and empowering junior leaders to solve problems. But the story also gets simplified in the retelling. Popular accounts often credit a single genius sergeant who saved the Normandy campaign. The reality was more complicated and more collaborative. Multiple units developed Hedgerow breaching devices simultaneously. The 79th Infantry Division had cutters operational by early July. The 19th Corps tested prong devices. The 5th Corps' units built their own versions. Culin's contribution was one among several, distinguished by the fact that senior commanders saw his demonstration and decided to scale it army-wide. The 4 men from the 102nd Cavalry who received Legion of Merit medals, Major Arthur Pinson, Captain James Dupuy, Captain Stephen Linton, and Sergeant Curtis Culin, represented a team effort. The welders who built hundreds of devices, Wesley Hewitt, John Jesson, Ernest Hardcastle, turned the concept into mass production. The tank drivers, Harmon McNaughton and John Huey, proved it worked under fire. All of them contributed essential pieces. 50 years later, military analysts studying the Normandy campaign identified the Hedgerow cutter as one of several key tactical innovations that enabled the Allied breakout. Not the breakthrough weapon that single-handedly won the battle, not a minor footnote without significance. One important factor among many that collectively overcame the bocage stalemate. The Czech hedgehogs that provided raw material had been placed on Normandy beaches by Field Marshal Erwin Rommel's engineers. They were part of the Atlantic Wall defensive system designed to destroy Allied landing craft. Thousands of them lined the invasion beaches, steel obstacles meant to stop the liberation of France. American mechanics turned those obstacles into weapons that helped break the German defense. They cut apart Rommel's beach defenses and welded the pieces onto tanks to penetrate his hedgerow defenses. The irony was lost on few observers. The Germans built elaborate obstacles to protect Fortress Europe. American sergeants recycled that German steel into tools that helped dismantle Fortress Europe. That kind of tactical and material improvisation characterized much of the American approach to World War II. The United States entered the war with less military experience than its adversaries. American forces had not fought a major war since 1918. Equipment and doctrine were often inadequate for actual combat conditions, but American units adapted quickly. Frontline soldiers identified problems. Mechanics and engineers devised solutions. Officers flexible enough to embrace unauthorized innovations gave their units tactical advantages. The Hedgerow cutter represents a specific case of a broader pattern. American forces didn't always have better equipment or tactics than their opponents, but they consistently showed ability to learn, adapt, and implement changes faster than enemy forces could counter them. That adaptability, more than any single weapon or tactic, contributed significantly to eventual Allied victory. In the town of Colombières in Normandy, near where General Bradley watched the first demonstration in July 1944, there is a small museum dedicated to the liberation. The museum displays artifacts from the Normandy campaign, photographs of soldiers, equipment used in the fighting. Among the exhibits is a section of steel beam from a Czech hedgehog, the type of material American mechanics used to create hedgerow cutting modifications. The label identifies it as scrap from German beach obstacles, repurposed by American forces to solve the hedgerow problem. Tourists photograph it during summer visits. Most don't understand the full significance of what they're looking at. Most don't realize that pieces of steel like this, salvaged from invasion beaches and welded onto tanks by soldiers working through the night, changed tactical options during a critical phase of the Normandy campaign. The museum also displays photographs of modified Sherman tanks, the distinctive four-prong attachments visible on their front hulls. The images show tanks pushing through hedgerows, dirt, and vegetation, exploding outward. The kind of breakthrough that had seemed impossible in early July. Veterans sometimes visit and point out details in the photographs, remembering specific battles, specific fields, specific moments when those modifications made the difference between getting through a hedgerow or getting killed trying. The modification worked because Curtis Culin and his fellow mechanics understood that complex problems sometimes have simple solutions if you're willing to ignore the rules long enough to test an idea. The army spent weeks trying to solve the hedgerow problem through official channels. Engineers tested explosives, ordnance evaluated bulldozer attachments, commanders revised tactical doctrine. None of it worked well enough. The solution came from soldiers who grabbed German scrap metal and started welding. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.